Okay, so this is 5.8. This is an application, so this is 5.8 part 2. And I'm going to go through on the calculator how to do example 3 on page 389. So this is the example, and then we'll go to the calculators. So the example is this. And the equation that we're going to type in, if you want to try to type it, is right here. You can go to the y equals. You can hit the y equals button, and then type that in. 20 minus 2x times 16 minus 2x times x, and then hit graph. So the way this problem works, except there's too much light right here and I can't do anything about it, is that you're gonna fold up this box. You're gonna fold up, you want to figure out how much you should cut into each square to make this box the biggest volume. That's the question. How long should these cuts in be? Tell me right now, let's think about the domain for x. What is the biggest possible value and the smallest possible value for x that would make sense in this problem? If I'm cutting into the box to fold it up, what's the smallest value of x that makes sense? How about -1? Can I cut a size of -1? Okay, so what's the smallest? One inch? I can't do a ½ inch? Okay, so 0 is the smallest cut. That makes sense. What about the biggest? Given that there's 16 inches of material, what would the biggest value of x be to cut into it? It would be halfway across, right? So you can't really go any bigger than 8 for the cut, or you'll overlap, and you can't do that when you cut a piece of paper or whatever, or a box. Okay, so we want to know where the maximum is between 0 and 8. So the way to set up the equation, we've done this before with applications. Does everyone see why this length? Everyone knows that volume, you multiply the 3 sides together. So does everyone see that this is the whole distance, 20 minus 2x, and this whole distance is 16 minus 2x, and the height is x? Are there any questions about why this formula is what it is for the volume? Because you're taking off the edges. If you cut into them, then the length is 20 minus 2x. So you multiply this together, you get an equation. So if we go, turn our calculator on and go to y equals, and you type in that equation, 20 minus 2x, 16 minus 2x, and x. 20 minus 2x, in parentheses, times 16 minus 2x times x. And then you hit the graph button, and it won't quite look right, and that's why we have to do it together to figure out how to adjust the window. So when you type that in and hit graph, yeah, would you mind turning off that other light? Thanks. This one. Oh.
Just lower that light.
You are so smart. I would not have thought of that in a million years. Okay. All this time, I thought it was impossible to do this clearly. Thank you, Floyd. So 20 minus 2x, 16 minus 2x, and x is what you want to type in. Wow, you just made my day. Okay, so then then we're going to go to graph, and it's going to look all funky, and that's where we have to use our knowledge of end behavior and x-intercepts to make it work. But we're going to do it together, so I just want to give you a chance to type it in. How many people are still trying to type in that equation? Oh, okay. You're waiting for me. So then you hit graph. Oh, because I already fixed mine. That's not what yours looks like though, right? So what you want to do is to make it look like this. First, you want to make x appropriate, okay? Remember how we talked about it only makes sense for x to be between 0 and 8 in the problem? So go to window, and make your x min and max something like between -5 and 12 so that the 0 to 8 is included in there. So go to window, and then make the x min negative, and be sure you use the negative button. Like the negative button is down here. Don't use subtraction. Use the negative button. And then the y values. Now, the y values, at first the local maximum will go off the screen, right? But if you adjust your y maximum to be something reasonable that you expect in the problem, like up to 500, if you change your y min and your y max to be that, it'll all fit on the screen. If you use these settings exactly and hit graph, and then let's try to figure out how to find the answer. So you hit, if you type those in, I'll move this here so you can see. So if you type those in to window, you hit window right here.
Wait, what did you type in window?
These values that you see right here. And then you hit graph, you'll see. And so how do you find that maximum? Here's what you do. You go to calculate, second, calc. So second and calc. Second, calc, and see how there's a thing called maximum? So you scroll down to maximum, you hit enter, and then you have to enter, you scroll to the left bounds, to the left of the max, hit enter, scroll to the right of max and hit enter, and then hit enter one more time, and it will pinpoint exactly where the maximum is. So I'll do it again. You go to second, calc, you go down to maximum, hit enter. Then, it doesn't just tell you the maximum right away. I think it does here because I've already done this. But you scroll to the left of it, hit enter. That's the left bound. Scroll to the right of it and hit enter. And then enter one more time, and it hones in exactly on the maximum. So what ends up working for our window settings was this, so that you have this down. For this example to work, you need your x min to be something like -5, your x max to be something like 12, your y min to be something like -10, y max to be something like 500, and always answer word problems with a complete sentence. So the maximum volume is 420.11 inches cubed. Make sure you have units. When you make a, how long? When you make a 3-inch cut. And you'll get to practice a couple more of these in today's assignment.